Welcome to Empowered Learning. Today, I'm excited to share with you some exciting advancements in AI and how we're leveraging these technologies with Claris FileMaker at Empowered Data Solutions. When it comes to AI, things continue to move forward at the speed of light. Today, we are going over,
Hey, Michael, mind if I jump in here for a sec?
I'm kind of in the middle of a demo here. Did you want to be involved or something?
I love FileMaker and you love AI, so I thought we would be a great team. So, Michael, can you tell us a bit about your journey into AI?
Absolutely. I started working with AI by exploring code completion using GitHub's Copilot. From there, I dove into using ChatGPT and prompt engineering, but I really wanted to understand how AI works. So I've been digging in all the way, including learning about synapses and machine learning and how the training works, in order to allow me to better work with higher level concepts like prompt engineering and semantic search.
That sounds pretty intense. Was there a particular moment or project where all this knowledge really paid off?
One instance that stands out was when I started using the OpenAI API to help a nonprofit who works with the homeless to match clients with services. That way they can find the best match for how they can help them. We did the matching based on surveys that were filled out by both the agencies and by the client. I've also used the LLM APIs to summarize a lot of tabular information about those agencies into easy to read and understand paragraphs, giving the clients important information easily.
So, you mentioned using GitHub Copilot earlier. How did that influence your approach to learning AI?
GitHub Copilot was my first real introduction to AI. It helped me complete code and handle tasks more efficiently. That really piqued my curiosity to learn more about LLMs and how the technology was exploding in that area. With everything that I've been learning, I wanted to invest back into the FileMaker community to help others get going into this wonderland.
Interesting. You call it a wonderland?
Seriously, I feel like I've fallen down a rabbit hole when it comes to all of this. Anyway, I've been working on a database to show some of the functionality of working with LLMs. I have a lot more that's almost complete beyond what is in this first version, so everyone should keep a lookout for those future versions.
Sounds like an exciting project. Can you tell us more about the basic chat functionality in your Empowered GPT database?
So when working to interact with LLMs in FileMaker, the most basic you can get is to send a prompt or a question and get back a single response. When doing this, there's no history or memory for the LLM to work with other than what you sent at that time. But even with this limitation, you can still do some pretty cool things. I have an example of that in this database.
That's cool. But what if you want to see more lines than just one at a time?
Here is a chat in the database that keeps track of the conversation in FileMaker record. You can just keep a list of records like this, or you can get more fancy and show the conversation in speech bubbles like this view.
That's fascinating. So, even with just a basic setup, there are a lot of possibilities. How do you handle more complex interactions where you need the LLM to remember previous parts of the conversation?
Well, the next level of complexity is to keep track of what has been said by the user and by the LLM and keep the LLM informed of past information. For example, if this conversation were happening through the chat API, then every time I said something to you, I would preface it with everything that you and I have said up to this point.
But there's a limit to how much an LLM can remember, right? It's called the context window. Essentially, it can only keep track of a certain amount of text. And once you exceed that, it starts to lose track of earlier parts of the conversation. How do you manage that limitation?
Well, we have to keep track of that and make sure we don't overwhelm you. As the conversation continues, I can either drop the older parts of the conversation that get too long, or a better way is to pause the conversation, a part that the user doesn't see, and go back to you and have you summarize the earlier parts of the conversation by passing that to you. Then I send the user's most recent chat with the summary of the past information and start building up more history again. But either way, in this method of working with LLMs, the FileMaker engineer is responsible for managing the context and history of the conversation. In a later video, I will talk about more advanced methods, like using threads with OpenAI's API to hold the conversation for the user.
It's a clever way to handle the context window limitation. Managing the context yourself can give you a lot of control over the conversation flow. So you mentioned summarizing earlier parts of the conversation to save tokens. How does that process work?
That is just another use of prompt engineering and sending a basic chat completion to the LLM. So the end user only sees the back and forth of them talking to the LLM. After they say something, I check how much information, how many tokens we have in total in the conversation. As we start filling up our context, or the LLM's memory limit, I send a prompt behind the scenes to the LLM to ask them to summarize maybe the first 3/4 of the conversation so far. It returns with that summary, and then I send the request with the summary and the rest of the conversation. We can continue like that, summarizing summaries and new information to keep a pretty good gist of the whole long conversation.
That's a really smart approach. It keeps the conversation coherent without overloading the LLM.
So this next section of the database is where I brought in data so that I can test the embedding and upserting, all the things to do with semantic search. When I got this list, it had the information like ISBN, book name, the author, publisher, etc., but it didn't have a genre or a summary. So I used the LLM and just the basic chat functionality, looping through these to have it fill out all of the information for the genre and the summary.
How did you manage to get accurate genres and summaries for over 100,000 books using an LLM?
Well, you're pretty smart and you know a crazy amount of information.
Thank you. I try my best. So, how did you harness all that knowledge to fill in the missing genres and summaries for your extensive book list?
I wrote a prompt, and in this case, I also used what is called a tool that I gave you to use. The prompt that I used said, "You are a research assistant for a publisher that is great at creating book summaries and getting the genre of books based on the book name, author, publisher, and ISBN of the book. The return summary should be 1 to 2 paragraphs and have as much detail as possible that is factual. If you do not know the book, then do not make up anything. Leave blank information that you cannot find. Return the answer as a JSON object with summary, genre, and a confidence score between 0 and 1. Only use the update book tool and do not return any other messages. The tool is simply a description of how I want the information that I'm asking for returned to me. I will go over this more in a future video as well."
That sounds like a very effective way to get detailed and accurate information. Using a structured prompt like that ensures consistency and quality in the data you receive. How did you handle the initial broad range of genres that the LLM provided?
Yeah, you were pretty creative when it came to book genres, returning over 300 different genres from the first 20,000 books. I then asked you to condense that list to a more manageable amount, and you took the list down to about 80 instead. I then updated the tool to tell you to only return one of those 80 when assigning a genre.
That's a smart way to narrow down the results and ensure consistency. So once you had your genres and summaries, how did embedding this data improve your database's functionality?
Embedding the data using OpenAI's Embedding API allowed for a couple of different functionalities. The first was a visual representation of meaning, which was very fascinating to me. When something is embedded by an AI model, it takes the data, whether that's a PDF, a few paragraphs, a photo, or a couple of words, and it creates a representation of the meaning of that data in an array of numbers. In this case, it was 1,536 numbers that represented the data with the embedding I was using. So to break it down more clearly, if I wanted to represent something like time or distance, I could do that on a single axis. I can represent more information by using both X and Y axes, like a grid or a map. 3 dimensions is what we're used to seeing in the world, and of course, it can hold a lot of information. But I honestly can't wrap my head around 1,536 dimensions. That's what's used to map meaning. Maybe you can explain that to me.
Sure, I'll give it a shot. When we talk about embedding data into 1,536 dimensions, we're essentially mapping it into a very high-dimensional space, where each dimension captures a specific aspect or feature of the data's meaning. Imagine it like capturing every possible nuance of a book summary in a way that each number represents a tiny piece of that overall meaning. It's beyond our usual 3D comprehension, but in this space, similar items end up closer together, making it easier to find related content through semantic search.
Yeah, and what really made it make more sense to me was when, in my study, I realized that some very smart people had come up with some algorithms to take that crazily complex 1,536 vectors and reduce it back down to 3 vectors that I can get my head around and even map. The geniuses even did it in a way that the relationship between the data is largely maintained. I used the TSNE algorithm, that's distributed stochastic neighbor embedding, if anyone cares, to reduce the embedding back down so I can do this. This is a 3D map of the embeddings of the summaries of those books. The genres were not embedded with that information, but just the summaries. But the wording of the summaries group the information together. So you can see they're color-coded by the genre, and you can see how the groups are mostly together. I also embedded the search on this map as a black point, and I show the items that came up as matches as solid colored diamonds, whereas the other points are translucent circles. This shows how the second use of embeddings works. Semantic search. As you can see, it's like going fishing where you throw the hook in the water and it ends up near the fish you want to catch. The semantic search is also used as a basis for RAG. We'll cover that in more detail in a later video, but why don't you talk about that real quick?
RAG, or Retrieval Augmented Generation, combines retrieval of external knowledge with text generation by retrieving relevant documents and using them to generate more informed responses. So how does it work? When you ask a question, a RAG system first finds relevant documents from a pre-indexed collection. Then it uses those documents as context for a generative model to create a coherent response. This approach has several benefits. It enhances accuracy because the responses are based on real data, making them more reliable. It also ensures the responses are more relevant as they draw directly from the pertinent information. Plus, it's scalable, efficiently handling large amounts of data, which is great for extensive applications. Looking back at your 3D map of book summaries, using RAG, a book recommendation system could retrieve summaries or reviews of related books and generate personalized recommendations based on semantic similarities and user. That should be an interesting video and example file when that's out. Try to hurry with that one.
There's definitely a lot to talk about when it comes to AI, and it's all changing so fast. So going back to semantic search, the way we've had to do it until recently involves using a third-party provider like Pinecone to store all of the vectors and allow us to search them.
Absolutely, AI is evolving at such a rapid pace. With semantic search, you're right, we've had to rely on third-party providers like Pinecone to store and search vectors. Pinecone has been great for managing and querying large sets of vectors efficiently. However, it's exciting to see how advancements are starting to bring these capabilities in-house, making it easier and more integrated for developers like us to implement semantic search directly within our own systems.
Before we go over what's new in FileMaker, let's go over the steps that we have to do in order to do semantic search using the OpenAI API and the Pinecone API. Why don't you give us a brief overview, and then I will show some of the scripts and show the functionality in more detail.
Let's go over the steps implementing semantic search using the OpenAI API and the Pinecone API. Here's a brief overview. 1. Embedding creation. First, you need to create vector embeddings for your text data. 2. Storing embeddings. Next, store these embeddings in Pinecone. Pinecone is a vector database that allows for efficient storage on query of these high-dimensional vectors. 3. Query embedding. When you perform a search, you need to convert the query text into an embedding using the same OpenAI API. 4. Searching vectors. Use the Pinecone API to search for vectors in your database that are most similar to the query embedding. Pinecone uses various similarity measures to find the closest matches. 5. Retrieving result. Finally, retrieve the original text data corresponding to the most similar vectors and present these as the search results. That includes scripting the find of the returned IDs and the sorting based on information returned from Pinecone. Now, let's dive into some scripts to show these steps in more detail.
I feel like I'm beating a dead horse right now, just going over and over about how many steps there are in doing the semantic search with Pinecone. It's really not that difficult. You're just making API calls if you've worked with APIs in the past. Here is your call that you're making to OpenAI to get the embedding, and this one is just to run through and do all of the embeddings, and it stores it into a field. Then we run through and do an upsert of the records, and that's pushing the embeddings up to Pinecone. So I did condense this into one script for handling most of the API stuff for Pinecone. And a lot of these other scripts are just interacting with that one. Here's the main Pinecone script. Creating an index, which is where you store the vector, a holding place for vectors. There's also namespaces, which are folders within the drawer of the index. You can list the indexes that are up on your Pinecone. Select a specific index. Get the information about an index. Describe the index. That has more to do with what vectors are in it. Do the actual query. So this would be after you get an embedding of your query information from OpenAI, then you do the query against Pinecone to get record information back. Just a quick walkthrough of these steps in the file. We have embedding the data, and this button here will do that. You can take a look at what embeddings are in the system. This is a calculated field that shows the embeddings from the container information, and I'll go over that later. This is not embedding, but this is what I put into the field after I push that embedding up to Pinecone. Then I put information about where I stored that embedding in Pinecone so that I just have that information here. Whenever you're doing an upstart or pushing those vectors up to Pinecone, you have to do it within an index. This is my Pinecone account. You can see that I have 2 indexes here. It also shows that I have 3 namespaces here. The default namespace, Ada002, and my own space. This one has 1 vector in it. This one has 103,000. This one has 104,000. So all of this information you can get from the database as well. By the time I release this file, you will be able to handle everything, including deleting indexes, deleting vectors, and everything. So this is how you select an index that you're going to query from. This tells me how many total vectors I have. As you can see, I said before that I had 104,000 and 103,000, and this gives me the 207,000 there. This shows that this particular record has been upstart or put up. And you can do finds for if the upstart is complete, what type of embedding this record has, and also how many dimensions. Some of the models allow you to use different embeddings less than the 1,536. If I were to push these up, then it's going to ask me for the namespace that I want to use. I can leave it blank for the default, or I can put in one of those namespaces, or I can add another namespace right here and it will upsert those into a completely different place. And it's fairly fast for pushing everything up. Shouldn't have to wait very long. There it goes. It does take a minute for it to be ready. Once you push up to Pinecone, it takes some processing time. Oh, there it is. There's my Mickey Mouse. So that 44 so far. So anyways, when you're doing your semantic search, then you can do it here. Again, make sure that whichever embedding you used to embed, that you're also using the same one when you're doing the semantic find.
There must be an easier way to do this. All these steps, from creating embeddings to storing and querying them, involve quite a bit of setup and coordination between different APIs. I wonder if recent advancements in FileMaker or other tools are simplifying this process. Let's dive into what's new with FileMaker and see how it might streamline these tasks.
You've been reading my notes. Yeah, Claris is introducing some new FileMaker script steps and functions that simplify this process. Insert embedding and insert embedding in FoundSet allow you to more easily connect to an embedding provider and then store those embeddings in FileMaker rather than uploading to a vector store like Pinecone.
It sounds like these new FileMaker script steps and functions are real game changers. Insert embedding and insert embedding in FoundSet make it easier to connect to an embedding provider and store embeddings directly in FileMaker, streamlining the whole process. So how does this new approach impact doing semantic search in FileMaker?
We have new script steps and functions for that too. Perform semantic find is FileMaker's way of searching those embeddings that were stored in container fields. But it doesn't just return a list of IDs like Pinecone does. With FileMaker's semantic search functionality, it works directly with the Draco engine to do the actual find and also sort the records that were found by their cosine similarity, or how much they resemble cert. So using FileMaker's new functions, doing the embedding actually puts the information right into a container field, and that container field is used for the semantic find. So no more storing it into Pinecone. It makes it a lot quicker and easier, and I'll show you the simplified scripts. And you can see right off that compared to several scripts, there are only 2 scripts related to this, the embedding and the semantic search. So very simple scripts, getting the API key and such, and then just doing the embedding. And then for the semantic search, it's very simple as well. We are connected to OpenAI via this configure AI account, and then we insert the embedding for the search criteria, and then we perform the semantic find, and that find does actually find in FileMaker. You don't have to do a find with information returned from somewhere else. And it also does a sort to sort by the most similar items, and it's all done. FileMaker is a little slower with a whole lot of records, depending on how many. If it's very many records, like hundreds and hundreds of thousands, Pinecone's going to beat it hands down. But for smaller record sets, FileMaker is convenient, and it's also plenty fast until you get up to over 100,000 records. And you can also get around that because FileMaker's perform semantic find also works just within the file set versus the whole table if you choose to do that. That means that you can do a FileMaker find first to narrow your search, and then do the semantic find on those records to find exactly what you're looking for. As you can see, the scripting for this is much shorter.
Wow, that sounds fantastic. Perform semantic find seems to really streamline the process by integrating directly with the Draco engine And I love that it sorts records by cosine similarity, making the result more relevant. The scripting is definitely much shorter and simpler compared to using third-party services.
What do you think? You think Claris is on a good track? Are you going to enjoy working with FileMaker and these great developers?
I think Claris is absolutely on the right track with these new features. It's great to see them making semantic search more accessible and efficient for developers. I'm definitely excited about working with FileMaker and these new tools. They're going to make a lot of advanced functionality much easier to implement. This is a big step forward for all of us.
Claris is working closely with developers like me as more and more functionality is coming to help us work with AI with ease. Well, thanks for helping with my presentation. Not what I was expecting, but we make a good team.
Claris is indeed making strides to bring developers like you closer to AIs like me. Thanks for letting me help with your presentation.
Thanks for watching, everyone, and keep empowering yourself to empower your data.